Hello everyone. In the last video, we have discussed the exact differential equation. We have discussed the Leibniz linear differential equation, Bernoulli's differential equation, and you can expect the question from the exact and these three topics. Definitely from the 5 marks question, at least 5 marks question will be from there. If the question will be little complicated, then it will be in the 10 marks question. So exact differential equation is very important. All the four cases are important. Whether if it is the homogeneous but not exact, then you have to find the integrating factor. If it is in the form of y, a function that's y f of x comma y dx plus x g of x comma y dy is equal to 0, integrating factor. If dou m by dou y minus dou n by dou of x divided by n is a function of x, then its integrating factor dou n by dou of x minus dou m by dou of y minus m, a function of y, then its integrating factor. So these things are important. Now what I am going to teach you in this session, which we are going to revise, is the complementary function, and the important thing is the particular integral. That's very important. Okay, 10 marks question, definitely one question will be from here. Okay, for example, as you know, we are finding the complementary function and the particular integral for the higher order differential equations. If the differential equation will be, for example, in this way: d square y divided by dx square minus 8 dy by d of x plus 15y is equal to 0. You can check that RHS is 0, as well as on the left hand side the derivative, the coefficient of the independent variable and the derivative is constant. So this is constant coefficient higher order differential equation. So how we are solving this? The RHS is 0, so it means the solution which we are going to find is by the complementary function. So in the complementary function, what we are doing, we are first converting it into, symbolize it into the d square minus 8d plus 15, and taking the y is equal to 0. So this is as a form of f of d y is equal to 0. Now find the auxiliary equation. So the auxiliary equation will be m cube minus 8m plus 15 is equal to 0. It is a quadratic equation, and you can find the solution by the quadratic formula, that's minus b plus minus root of b square minus 4ac will be the value of m. So that is minus and minus, that is plus 8 plus minus root of 8 are 64 minus 4 times 1 times 15, okay, divide by, and that is 2 times 8, that's 2, and here you will get a 2 solution, that is 3 and 5. Or you can write m minus 3 and m minus 5 is equal to 0. So you have the 2 solutions, 3 and 5, and both are the real, both are distinct. So the complementary function will be c1 e raised to the power m1. So you have the m1 is equal to 3, m2 is equal to 5. So m1x plus c2 e raised to the power m2x. So you have c1 e raised to the power 3x plus c2 e raised to the power 5x. So it implies the solution will be c1 e raised to the power 3x plus c2 e raised to the power 5x is the solution. Okay. So this one is the solution, this is the complementary function. Okay, so now for example, they will give another differential equation of the third degree, that is d cube y divided by dx cube plus 2d square y divided by dx square plus dy by d of x is equal to 0. But will you check the coefficients are the constants, so you will do to symbolize it as f of d, so that is d cube plus 2d square plus d, okay, so plus d of y, isn't, because here we have the derivative, so we are writing d is equal to 0. So now what is the auxiliary equation? That's m cube plus 2 m square plus m is equal to 0. Take the m common, you will get m square plus 2m plus 1 is equal to 0. So it implies m is equal to 0, or m square plus 2m plus 1 is equal to 0. So you can write this as m, okay, m plus 1 ka whole square is equal to 0. So it implies m is equal to 0, or m plus 1 is equal to 0, or m plus 1 is equal to 0, because you have the square here. So that is m is equal to 0, m is equal to minus 1, and m is equal to minus 1. So you have the three roots, 0, minus 1, minus 1, all are the real roots. So your complementary function will be equal to c1 e raised to power 0x, and these two are the same, so you write c2 plus c3 of x e raised to power minus 1x. So you will get anything raised to power 0 is 1, so c1 plus c2 plus c3x e raised to power minus x. So as your x is equal to 0, RHS is 0, so it means that y is equal to c1 plus c2 plus c3x e raised to power minus x is the solution. So this is the way how we are finding the complementary function of the differential equations, okay, of constant coefficient. Similarly, you can try to find the solution of this one as well. Let's write it: d cube y dx cube minus 2 dy upon d of x plus 4y is equal to 0. As I told you, I have to symbolize it: f of d into y is equal to x. X is already 0, you can check it. So what you can write: d cube minus 2d plus 4, so of y is equal to 0. What is the auxiliary equation? That is m cube minus 2m plus 4 is equal to 0. So you can check by hit and trial method that if you put m is equal to minus 2, it will be minus 2 whole cube minus 2 plus 4. You can check, it is 2 to 4 to are 8 plus 4 plus 4, so it will be equal to 0. So that means m is equal to minus 2 is a root. So what will you do? You divide this m plus m cube minus 2m plus 4 divided by m plus 2, okay. So you can write then this equation, or you can write divide it in this way as well. So you will write m square, so it will be m cube plus 2m square, so it will be minus 2m square minus 2m plus 4, and as you divide, so you will get a quadratic equation and you find the more two roots. Or as you find the minus 2 is a root, so you can write it in this way: m cube plus 2m square minus 2m square minus 4m plus 2m plus 4 is equal to 0. So you can write it: m square m plus 2 minus 2m m plus 2 plus 2 m plus 2 is equal to 0. So m plus 2 m square minus 2m plus 2 is equal to 0. Okay, same you will get here as, okay. So from this you will get the quadratic equation. So you will sorry, from this you will get the roots, the two roots. So that's minus b plus minus root of b square. So the two roots will be minus 2, 1 plus minus iota. So this one is real, this one is complex. So what is the complementary function? c1 it is for real root minus 2x plus, now we have the here complex roots, so alpha is equal to 1 and beta is also equal to 1. So that is e raised power alpha x, that is 1x c2, because c1 is here, c2 cos of beta x, beta is 1, plus c3 sine of beta x. So that is y is the solution, the same, okay. Similarly, you can try the question in this way: d square y by dx square minus 2 dy upon d of x plus 10y is equal to e raised to power 2 of x. Now you can check that on the RHS we have the exponential function as f of, if you will convert this function as a symbol, symbolize it by the d, then you will write it d square minus 2d plus 10 of y is equal to e raised to the power 2x. So now this is your f of d, so your it is now f of d of y is equal to x, so your x is e raised to the power 2x. Okay, so they will ask you to solve this differential equation. So first solve it by the complement, find its complementary function. So the complementary function, you have to find the auxiliary equation, that is m square minus 2m plus 10 is equal to 0. By the quadratic formula, you will check its root will be 1 plus minus 3 iota. That means it is complex, so the complementary function will be c1, sorry, yes, e raised to the power alpha is your real part, that is 1x, so that's e raised to the power x, c1 cos of beta is 3, so 3x plus c2 sine of 3x. So this is your complementary function. And what is a particular integral now? As you know, the particular integral is 1 by f of d of your RHS. So that is 1 by, that is f of d is d square minus 2d plus 10 e raised to the power 2x. So this is the case when you have x is equal to e raised to the power ax, then your f of d is becoming f of d is equal to a. Okay, so now replace it with the a, so it will be every d you have to replace it with the a, so it will be 2 square minus 2 into 2 plus 10 e raised to the power 2x. So that is 2 to our 4 minus 4, that is 0. So that is 1 by 10 e raised to the power 2x. So this is your particular integral. So the solution is complementary function plus particular integral. It is equal to e raised to the power x c1 cos of 3x c2 sine of 3x plus 1 by 10 e raised to the power 2x is the solution. Similarly, they will give the question d square y divided by dx square plus dy by d of x minus 2y is equal to e raised to the power x. You have to solve this. As I told on the RHS, you have the e raised to the power x, so you will convert it into the f of d of y is equal to x. So now what is f of d? D square plus d minus 2 of y is equal to e raised to the power x. Your x is now e raised to the power x. It means that your a is equal to 1 when you have a is ax. Okay, so now what is the complementary function? As you have to solve it, so auxiliary equation is m square plus m minus 2 is equal to 0. When you will find it, so it will be minus 2 and 1. So complementary function, both are the real and distinct, so that c1 e raised to the power minus 2x plus c2 e raised to the power 1x, that is e raised to the power x. So your particular integral will be 1 by f of d of x, so that is 1 by d square plus d minus 2, x is e raised to the power x. So your a is 1, so replace it by the a, so that's 1 square plus 1 minus 2 e raised to the power x, so that is 2 minus 2, it is 0, so it means it is a failure step. Okay, so your denominator is becoming 0, so we can't do it. So what you have to, you have to differentiate this function, so it will be equal to x e raised to the power x. You have to multiply and on the differentiation, so that is 2d plus 1. Now your a is again 1, so x e raised to the power x divided by 2 into 1 plus 1, that is x e raised to the power x divided by 3. So this is what now particular integral. It means that the solution will be c1 e raised to the power minus 2x c2 e raised to the power x plus x e raised to the power x divided by 3 is the solution. Similarly, they may ask you the question that if you have the differential equation as d square. Okay, so now if the question will be of this type, d square plus d minus 2y is equal to sine x, and they will ask you to solve this differential equation, and it's given that you have the f of d here and this is your x, so it is f of d of y is equal to x, so the x is sine of x. So first of all, you have to find the auxiliary equation, that's m squared plus m minus 2 is equal to 0. By the quadratic formula, you will find that your m will be minus 2 and 1. So both are the real and distinct, so it means that the complementary function will be c1 e raised to the power minus 2x and c2 e raised to the power x. Now the particular integral, that is 1 by f of d of sine of x. Okay, so that is 1 by d square plus d minus 2 sine of x. And as I told that if you have sine of ax plus b as your RHS, then the 1 by f of d you have to make it f of d square is equal to minus a square. So what is your a here? So here in this case ax means a is equal to 1, so your minus a square will be minus 1 1 or 1. So you have to put d square value as a minus 1. So d square is minus 1 plus d minus 2 sine of x. So now it is 1 by d minus 3, okay, sine of x. As I told that in the particular integral, when you have the sine or the cos, what you have to do, you have to use the d square here. So now you have only d. What you will do, you will rationalize it. So multiply d plus 3 on the numerator and d plus 3 on the denominator. So it will be equal to d plus 3 d square minus 3 square, that's 9 sine of x. So that is d plus 3 d square. As I told, d square you have the minus 1. So that is minus 1 minus 9 sine of x. So that is minus 1 by 10 d plus 3 of sine of x. Now minus 1 by 10. Now d of sine, that is differentiation of sine, that is cos of x plus 3 sine of x is your particular integral. So your solution is the complementary function that you know c1 e raised power minus 2x plus c2 e raised power x, and your particular integral, that's minus 1 by 10 cos of x plus 3 sine of x is the solution. Now the question will be of this type as well. That means on the RHS you have the cos. For example, the question to solve the differential equation as d cube plus 2d plus 1 of y is equal to cos of cos square x. So in this case, again you have to find the auxiliary equation, that is m cube 2m plus 1 is equal to 0. So again by hit and trial method you will get as m is equal to, or you can just make it the square, it will be easy. So by the quadratic formula, so you will get m is equal to minus 1, both are the real and equal. So the complementary function will be c1 plus c2 of x e raised power minus 6. Now the particular integral, that's 1 by f of t of x, that is cos square x. So that is 1 by, what is what f of d? D square plus 2d plus 1, and your cos square x, you know, you can write it as 1 plus cos of 2x divided by 2. Okay, so now you have here that 1 by d square plus 2d plus 1. Okay, so of 1 by 2 plus 1 by d square plus 2d plus 1 of cos of 2x. Now as you have the case with the e raised power x, you have the case with the sine of ax plus b, you have the case with the cos of ax plus b, you have the x raised power m. So we will convert it into the e raised power ax. That will be easy. So 1 by 2 common, we will do 1 by d square plus 2d plus 1 into e raised power 0x, that is equal to 1. So now 1 by d square plus 2d plus 1 cos of 2x. Now when you have the ax, so you have to replace d by a, so it will be 1 by 2, so d here it is 0, so 0 square plus 2 times 0 plus 1, it is for 0x, plus now you have to replace here as cos of 2x, that means a is equal to 2 minus a square will be minus 2 or 4. So you have to replace d square by the minus 4. So that is d square is minus 4 plus 2d plus 1 cos of 2x. So now here it will be 0 square is 0, 2 times 0 it will be 0, it will be 1 by 2 only. Okay, so plus 1 by 2d minus 3 cos of 2x. Okay, so what will you do? Similarly, now here as you have the 1 by 2, so plus you will take the 1 by 2 as common, you will get 1 by d minus 3 by 2. Rationalize it, d plus 3 by 2 and d plus 3 by 2 cos of 2x, because you need the d square. So 1 by 2, 1 by 2 d plus 3 by 2 d square minus 9 by 4 cos of 2x. As d square is minus 4, so it is 1 by 2, 1 by 2 times d plus 3 by 2, d square is minus 4 minus 9 by 4 cos of 2x. So that's 1 by 2 plus 1 by 2 times this, that is 1 by 2 times 4, 4 are 16, so that is 4 by 2, so 2 2 are 4, so that is d plus 3 by 2 and this will be 25. Okay, and that is also minus, so we will take the minus here, cos of 2x. So now 1 by 2 minus 2 by 25 d with the cos of 2x, that's the differentiation of cos of 2x is minus sine of 2x and 2, that is minus of 2 plus 3 by 2 cos of 2x is the particular integral. Now the solution is the complementary function that we have plus the particular integral that you got here. Okay, so this is the case with the sine x and the cos x. Now if your x is a polynomial, for example the question will be d square y by dx square minus y is equal to 5x minus 2. Now here on the RHS you have the polynomial, you have to solve it. So what will you do? First symbolize it, so that is d square minus 1 of y is equal to 5x minus 2. Auxiliary equation will be m square minus 1 is equal to 0. M square is equal to 1, m is equal to plus minus 1. Both are real and distinct, so complementary function is c1 it is for x, c2 it is for minus x. Particular integral will be, so in the particular integral if you will check, that is 1 by f of d 5x minus 2, so that's 1 by d square minus 1 5x minus 2. So as I told that here, what you have to do, you have to make it as a binomial one. So take the minus common, so you will get it 1 by 1 minus d square minus 5x minus 2. So now use the binomial theorem that you will get it minus 1 minus d square or is it power minus 1 5x minus 2. So you will use the 1 minus x whole is for minus n from minus 1 formula, that is 1 plus x square plus x cube. So here what you will get? You will get minus 1 plus d square plus d4, okay, plus so on. 5x minus 2. Now you, what is this d? As a differentiation. So minus 1 times 5x minus 2, that's 5x minus 2. Double differentiation of 5x minus 2. Differentiation of 5x minus 2, that is 5. Now again the differentiation it will go 0. So after this it will go 0. So your solution is minus 5x plus 2 is the particular integral. The solution is complementary function. Y is CF plus PI and write it. It will be the solution when your RHS is the polynomial. Okay. Please try this one question. This is very important. The question will be, for example, d square plus 2y is equal to x square e raised to the power 3x. So here you have the product. Okay. So auxiliary equation m square plus 2 is equal to 0, m square is equal to minus 2, m is equal to plus minus root of 2 iota. Complementary function, it is complex, so alpha is 0, beta is root 2. So complementary function c1, first e raised for real part, that's 0x, that is 1, so I will write directly c1 cos of root 2x plus c2 sine of root 2x. Now your particular integral, that's 1 by f of d of x, 1 by f of d square plus 2 x square e raised to power 3x. When you have the product of the e raised power x with any polynomial, what you will do, you have to take the e raised power x as out and make the d as the d plus e. So here a is 3, so what we will do, we will take the e 3 raised power x out, so your form will be d plus 3 whole square plus 2 x square. Okay, it will become e raised power 3x a plus b ka whole square plus 2, so it will be d square plus 6d plus 11 x square. So now take the least term out, that's our 11. Okay, so take the 11 out, you will get 1 by, that is 1 plus d square plus 6d divided by 11 x square. Take it on the numerator, because you have the polynomial, so you have to always use the binomial. 1 plus d square plus 6d divided by 11 whole raised power minus 1 x square. Use the binomial theorem and solve this. So it will be 1 plus x whole raised power minus 1, and you have the formula e raised power 3x by 11, that is 1 plus x, so that is 6d. Okay, 6d by 11 plus d square by 11, okay, plus 6d by 11 plus d square by 11 whole square plus so on. And you have to check up to which differentiation we can get x square. If you have the differentiation of x square, that is 2x. Double differentiation of x square is 2. Triple differentiation of x square is 0. So up to d2 we will consider. So it will be it is for 3x by 11 and 1 times x square, that's x square. Now you have to differentiate the x square and multiply 6 by 11, it will be 12 by 11, and in this way you will get minus 12 by x by 11 and plus 50 by 1 to 1 is a particular integral, plus the complementary function will be the solution. Okay, so this is about the complementary function and the particular integral, all the 4 cases. Yes, please do practice this question as well. D square plus 2 of y is equal to or plus 1 y is equal to e raised power 2x sine of x. When you will take the e raised power 2x out, so it will become d plus 2, and solve this equation. The last topic that's in your syllabus is the homogeneous Cauchy homogeneous higher order differential equation. Okay, so for this one we know the general form, or go through the last video, there's a video number 13, and let's practice some questions here. For example, the question will be here, now x cube d cube y by dx cube plus 3x square d square y by dx square plus x dy upon d of x, plus we have here as 8y is equal to 13 cos of log of x. X is greater than 0. So now as we use the complementary function particular integral, that there we have the constant coefficient. Now we have the coefficient as x cube, x square, x. So what we will do, we will just put this x in the Cauchy case. we will put the x is equal to e raised to the power z. It means that the z will be equal to log of x. So it implies that dz upon d of x will be equal to 1 by x. But in our equation, it is dy by d of x, d square y by d of x, and dqy by dx cube. So now that means dy upon d of x will be dy upon dz and dz upon d of x. So that will be equal to dy upon dz times 1 by x. So x times dy by d of x is equal to dy upon dz. So it means that we have this term now x dy by d of x as dy by d of z. Similarly, we have d square y by dx square. So with this we have the x square. So it will be, so if this dy by d of z, we will write it as d is equal to d by d of z. So it will be equal to d into d minus 1 of y. Similarly, x cube d cube y by dx cube is equal to d into d minus 1 d minus 2. If anyone wants to check how it is coming, so go to my last video, we have explained it there. So now if we will replace every d cube y by dx cube x square d square y by dx square in the above, so it will become now as x cube d cube y by dx cube. So it will be d minus 1 d minus 2 plus 3 times x square d square y by dx square, that is d and d minus 1. Okay, now plus x dy by d of x. So we have seen that is d plus 8 of y is equal to 13 cos of log of x. So now this one will be d square minus d times d minus 2 plus 3d square minus 3d plus d plus 8 of y is 13 cos of log of x. So solve this one, you will get d cube plus 8 y is equal to 13 cos. Okay, so our x is e raised to power z, so we have to replace this e raised to power z, and it is e raised to power z, and log and e will go cancel, so we have the cos of z here. On the RHS we have the 13 cos of z. Okay, so now here in this cos of z, what we will do, so we have to find, now we will check that the coefficient is now constant. So check the auxiliary equation. So auxiliary equation is m cube plus e is equal to 0. Find the m and find the particular integral, replace the z, you will get the solution, and you have to follow the previous. Okay, you can try this question as well, that is x squared d squared plus 2x d minus 4y is equal to x squared plus 2 log of x. And you can check with the differential coefficients. Here you do not have the constants, you have the x coefficients, so that means it is Cauchy. So again put x is equal to e raised power z or e raised power t, so differentiate it, so z will be equal to log of x, differentiate, so convert it into the differential equation of the constant coefficients and find the solution as a complementary function, particular integral, and convert it back to the in terms of the x, and you will get the solution. But not always you will get the coefficients only in the x coefficient. Sometimes you will get the more general case. For example, you will get 3x plus 2 whole square d square y by dx square plus 3 times 3x plus 2 dy upon d of x minus 36y is 3x square 4x plus 1. What will you do? Here you will check that the coefficient contains the form ax plus b, so it means it is a Legendre's differential equation. So there we are putting x is equal to e raised power t, so or e raised power z. Here what we will do, so we will put that 3x plus 2 is equal to e raised to the power z. So z will be log of 3x plus 2. So dz upon d of x will be 3 by 3x plus 2. So it means 1 by 3 dz upon d of x is equal to, okay, you need only dz by d of x, so leave it as it is. So then you have the dy by d of x, that you can write dy by d of z dz upon d of x, so that is dy upon d of z, and here you will write 3 divided by 3x plus 2. So now you have the dy upon d of x 3x plus 2, so take it on the LHS. So 3x plus 2 dy upon d of x is equal to 3 times dy upon d of z, so 3d of y. Okay, similarly 3x plus 2 whole square d square y by dx square is equal to 3 square d minus 1 of y. 3x plus 2 whole cube d cube y by dx cube is equal to 3 cube d minus 1 d minus 2 of y. Now replace all these terms by the d. You will get a differential equation of constant coefficients and solve it by that method, and you will get the solution. Thank you very much.